Auzubillahiminashaitanirrajim. Bismillahirrahmanirrahim. Assalamu alaikum. Uh, Hello and a good morning to everyone. Welcome once again. Here we have subject chemistry class 9, the same chapter, sixth solutions. You can open your page number 116. Here we have a new topic today. Topic molarity. The symbol of molarity will be M, capital M. We will uh, uh, mm, represent molarity with M. What is a molarity actually? Uh, it is just a unit which is frequently used for description of a solution's component. Uh, Molarity is number of solute dissolved in per liter of a solution. Uh, by molarity, it is unit. We want to describe, we want to determine that how much solute is dissolved is per liter of a solution. Means that there is a given amount of liter solution per liter. We just see that how much solute is dissolved, means how many number, what is the number of solute dissolved in 1 liter of solution. Actually molarity means this is the unit used for well description of solutions components. Actually, what are the components of solution, what are the components of solute in a solution. Also the number of moles of solute dissolved per liter of solution. It means how much solute is dissolved. This unit describe the components of solution. How, like for example, if we have sodium chloride 0.1 mole. If a person say that say that there is sodium chloride 0.1 mole, so mole means molarity, so it means we want to describe the number of the sodium chloride, means the component of the solution. Means 0.1 moles of sodium chlorides are there dissolved in 1 liter of aqueous solution. If a person say there is 1 mole of sodium chloride in the solution, so it means there is 0.1 mole of sodium chloride dissolved in 1 liter of aqueous solution. So this is actually the molarity. Formula for molarity, that is molarity M is equal to number of moles of solute divided by volume of solution in liter. So in molarity we just keep one thing in our mind, that when we divide the moles of solute, the solute will be measured in moles. As a molarity, as mole is a unit, the solute, when we measure this the percentage or the number or the quantity of solute in moles, and we divide it on the whole volume of the solution, and the volume of the solution will be in liters, then the molarity came out. So this is the formula for molarity. Problems involving the molarity uh, of a solution. Which kind of problems will be there? For calculating molarity of a solution or the amount of solute in a molar quantity, this formula is used. For example, if we have a problem to calculate the molarity of a solution, so we have to use this formula, or if we have the problem to collect the amount or to calculate the amount of solute in a molar quantity, also we can use this formula. So this formula is used as molarity is equal to mole upon amount of solution in liter. Mole upon amount of solution in liter means, mole means we are calculating the or we are describing the solute quantity, and amount of solution in liter, it is the whole volume of the solution. Or we can use this formula, molarity upon number of moles of solute, volume of solution in liter. So this is the easiest formula for the problem solving regarding this molarity. Simple formula is also there. This mass molarity is equal to mass of solute. Okay, you can see mass of solute uh, divided by molecular mass of solute multiplied with amount of solution in liter. So molecular mass uh, of solute multiplied with the amount of solution, then the result will come out and the molarity. So this is the simple formula for example. Here is an example given in your book 116 page number. It says that example 6.4, calculate amount of sodium hydroxide required to prepare its 0.1 mole solution in 500 milliliter of waters. So here we have three things: amount, required amount, and given amount, and also the amount of solution and the amount of prepared solution. So as we know that the molarity calculation involves the use of formula. So the formula, the same formula is here, previous in which is in previous slide. Molarity, mass of solute, molecular mass of solute multiplied with amount of solution. So this formula we have: mass of solute divided by molecular mass of solute multiplied with amount of solution in liter. So liter solution should be in liter as it is given in the question, 500 milliliters of water. This is the amount of solution in liter. And also we have the amount of molecular mass of solute. Molecular mass of solute we have here, which is given in 0.1 mole of mass of solute is here. Or we can use the formula mass of solute. Mass of solute is dividing here. When we put it on the other side of the arrows of the equal symbol, so it will be multiplied. So molarity is multiplied with molecular mass of a solute multiplied with amount of solution in liters. Now we want to molarity is with 0.1 with us. Prepare its molarity 0.1 molarity of solution, and molecular mass of solute is 40 with us, and 0.5 is or this total solution, 500 milliliter of water. When we multiply these with each other, so it will mass of solute will be 2 grams. So if 2 grams of sodium hydroxide is dissolved and FOH is dissolved in 500 milliliters of water, it will give 0.1 mole solution of sodium hydroxides. Okay, here we have homework for students. Activity number 6.2 from page number 117. How will you prepare a 250 milliliter of a solution of 0.5 molarity mole of NaHCO3? So this is homework per student. Should we solve this question according to the previous examples, example 6.4 on page number 116, and the same formula should be applied there. So this should be solved by the students and will be checked by the teacher and at school. Another topic, dilution of solution. What is dilution means to dilute the solution. When a solution is given to us and we want to dilute it, we want to thin it according to our desire. So this is called dilution. Actually, dilution is the process of diluting or thinning of a solution up to a desired level, what we want. To that level we can increase the number or the quantity of solvent. By increasing the quantity of solvent we can dilute a solution. So this process is called dilution of solution. There is a simple relation between required solution and given one. If a solution is given to us, that dilute it up to which level, so that is called required solution, and the given solution. So there is a simple relation. That relation can be expressed here as m1 v1 and m2 v2. Here m1 and v1, they are molarity and volume of dilute solutions, while m2 and v2 are molarity and volume of concentrated solutions. The solution which is given to us, that is the molarity of that solution is m2, and the volume of the concentrated solutions means the given solution, that is v2. The solution which we make dilute to our up to our desired level, which we want to dilute, that will be expressed by m1 and v1. M1 means the molarity of that solution which we are going to dilute, or which we have diluted, and the v1 is the volume of the dilute solution. You can understand in the next slide. M1 v1, molarity and volume of dilute solution, means the required solution which is given to us, and it's said to us that dilute this solution up to this level. That we will the relation with volume and molarity, that will be expressed here m1 and v1. And m2 v2 is equal to molarity and volume of concentrated solution, the given solution which is given to us. That solution is the relationship of that solution will be expressed by m2 and v2. M is equal to molarity and v means volume. 1 and 2, it means 1 means provided one and 2 means required solution. So these are for required and provided one. This is 2, m2 v2. It is not 1, it is 2. Example number 6.5 on page number 117. With the help of this example you can more understand dilution of solution. Here is requirement: what is the volume of HCl required to prepare 500 milliliter of 0.1 mole solution from the commercially provided 36 mole HCl acid. So here is three things are required. One thing is required, that actually they want the volume which is required of HCl, which is required. They are what they want to prepare solution of 500 ml and molarity of 0.5, and commercially they have provided us 36 mole of HCl acid. Now they want that how much HCl is required. So we are going to put the same formula: m1 v1 is equal to m2 v2. This formula we have to put it, the same formula, m1 v1 and m2 v2. This process required the dilution process. The formula that will work is m1 v1 m2 v2. So we are going to put all the values here in this formula. By putting values, by inserting values in this formula, M1 molarity of commercial HCl that is given to us in question, commercially provided 3.6 mole HCl acid. So we have to put it here. And volume of commercial HCl that is required. What is the volume of HCl required? So that is commercially required HCl that is unknown. We have to find the value of this one. And M2 molarity of required HCl. Molarity of required HCl, that is required HCl is 0.1 mole solution. We have to put it here. And V2 volume of required HCl. Total they required 500 milliliter of solution. They required, so we put this formula here. So by inserting values in the given formula, we get M1 V1, M2 V2. Now we are going to put all the values in this formula. 36 mole, this is the value of molarity of commercial HCl. Okay, commercial HCl, that is 36. It is multiplied with V1. V1 we don't have the value of V1. We have to find out the value of V1. That is volume of commercial HCl. So is equal to M2. M2 what we have, molarity of required HCl, that is given in the question 0.1 mole. That is here we put it. And V2 we have volume of required HCl. They asked in the question, they required to prepare 500 milliliters of solution, so we put it here. By changing this 36 M1 to the other side of the equal, first we multiplied 0.1 with 500, and this 36 is divided by the result of multiplying 0.1 with 500, then the V1 will give us the value 1.39 ml. So this is the result. Solubility, another topic here we have. Solubility is actually the capacity, actually the quality, actually the ability. Solubility is the ability, capacity, quality of what? Of being soluble, of being dissolved. The capacity of dissolving, the capacity of solving, the quality of solving, and the ability of solving or dissolving. This is called ability. When something has the capacity, quality, or ability to dissolve or being dissolved, that is called the solubility of that substance. The amount of substances that are able to dissolve in the given quantity of solvent at a particular temperature is actually the solubility of that substance. The number of grams of R, there is another definition. The number of grams of solute which are dissolved in 100 grams of solvent. That is scientifically definition. The number of grams of solute which are dissolved in the 100 grams of solvent is actually called the solubility. It means all those substances that has the ability, capacity, or quality to dissolve or being dissolved is called the solubility of those substances. And this is the last factors affecting solubility. Which kind of factors actually affect the solubility? Number one, nature of solute and solvent. Which kind of solvent is there and solute is there? What is the nature of solute? What is the nature of solvent? How which kind of nature of solvent has, and how can they dissolve things in itself? And what is the nature of solute? How it is being dissolved? So first thing, nature of solute and solvent. this affect the solubility of substances. And second thing, like dissolve like means same thing dissolve same thing, like dissolves likes. And polar dissolve polars means sodium chloride in water, because both are polar. Polar means they have ions, they have poles on their ends, means they either they have negative charges or positive charges. And non-polar dissolve non-polars, like petroleum jelly in benzene, because they both are non-polar. So means non-polar dissolve uh, if the solvent is polar and the solute is also polar, like here the solvent water is polar and the solute sodium chloride is also polar, so it dissolve it in it means polar dissolve polar, means solvent is polar, it dissolve only polar solutes, and non-polar dissolve non-polar. So and temperature also affects solubility. By increasing temperature, the solubility is increase of any substance, but decreasing temperature, the ability of any substance is decrease. So this is all about today's topic. Thank you, students.